All right, hey guys, whoever's watching this video, this is 3 complex numbers. Okay, complex numbers. People like complex numbers after they've had them for like a couple days. People hate complex numbers like the first day you see them because you don't know how they work, okay? But they're very easy. It's all algebra. It's all just like x's, dealing with x's, okay? So don't get discouraged. Complex numbers are not that bad, okay? Here we go. Complex numbers. Let me give you a little intro into what complex number does, okay? Every number that you can ever think of is something called a real number. So there are numbers that are in real number land. There are real numbers like the square root of 2, or 7, or -13, or pi. Those are all real numbers. Those are in real number land, okay? And every number that you can ever think of is a real number except for numbers that are called imaginary numbers. So it's like we thought we were like done with all the real numbers, right? Like we knew everything, but we don't. We have another subcategory which is called imaginary numbers, okay? And imaginary numbers aren't too bad. They involve eyes. You people who are taking, like on the MAPS test, if you were scoring really well on the MAPS test, chances are you got like a ton of these, right?
So many.
You're going to learn what those are today. Imaginary numbers. This is what they are, okay? So MAPS testing, if you saw these, this is what they are, okay? Now, imaginary numbers have a specific purpose, and we're going to go through that. This is why they exist. Are you ready? Okay? We are not allowed to take the square root of a negative number, correct? Okay? So an imaginary number, which is labeled as I, is equal to the square root of -1, okay? We're not allowed to take the square root of a negative number, so the value of I, what I is equal to, is the square root of -1. Write that down. It's also at the top of your paper, but write it down also, so you can remember that, okay? I is equivalent to the square root of a -1, okay? It's an imaginary number, because we can't do it, right? We can't take the square root of a -1. We can't do the square root of negative numbers. Therefore, we label them as imaginary numbers, right? Okay? So let me give you some examples off to the side over here of how we would simplify some of these things, okay? So let's say, for example, we have the square root of -4, all right? Normally, the square root of +4 is just 2, right? And this would just be 2i, right? Because the square root of a -1, or the square root of a negative number, is an imaginary number, and this is just 2i, right? Okay? So given that, what would the square root of like -36 be? 6i, right? Okay? Now, Reese, Payne, boy Reese, put your leg down and write this stuff down. You're going to want to have this, okay? Now, if it doesn't come out nicely, like let's say you have the square root of -12, let's say. Let's say we have the square root of -12 instead, okay?
What does that say?
Can you take, what?
Does it say 2i?
That says 2i on the top.
Okay.
Okay, you can't take the square root of 12, right? It doesn't come out perfectly. It's a decimal number. So what we do instead is we break down the square root of 12. So I'm going to do that off to the side over here. Do you remember doing this in like chapter 0?
Yes.
The square root of 12 breaks down into 2 numbers. I want numbers that I can take the perfect square root of.
4.
4 and 3, okay? So we would say that the square root of 4 times the square root of 3 will give me the square root of 12, right? Square root of 4, square root of 3 gives me the square root of 12, okay? But what is the square root of 4? 2. And the square root of 3?
3.
Doesn't come out nicely, so it's just the square root of 3. So this square root of -12 will become 2 square root of 3, but we need I in there, okay? So now, where do you put the I?
So much.
Where do you put the I?
Behind the 2.
After.
Behind the 2, behind the 3, which one do you do?
I say behind
the 2.
I'd say behind the 2.
It is acceptable to put the I
After the whole thing.
here, or you can put the I
After the whole
here. The only thing that I will caution you on is if you're going to do this, the second one, make sure that your I is not underneath of the bar. Correct? Sometimes if your bar gets a little long, make sure that I is not traveling underneath of there. That he is obviously outside of the square root. Make sense? Okay? So either one of those are acceptable. 2 square roots of 3i or 2i squared of 3. That's how you would break it down. Yes? So imaginary numbers exist because you can't take the square root of negative numbers, and we need to have something in place for that. What?
Can
You hated these? What?
Can you have I first?
Can you have I first?
Like if it was I too.
Typically you can, but I treat I like it's an X. So like if you have 2X, you wouldn't say X2, right? Does that make sense? Like I think of I as like just a variable number. So you could technically have the I in the front, it wouldn't matter, but it just kind of looks weird. Yeah. So anyway, all right, now next. The next thing that you have to remember for complex numbers or imaginary numbers is this. Okay, you ready? And this kind of follows straight from this information. We know that the square root of -1 is equivalent to I. What happens if I square both of those? Like if I square the I and I square that one. Like what is I squared equal to?
1.
You're close.
It's -1.
This will cancel out, and I squared is just -1, right? Because the square and the square root would cancel each other out, okay? So they say that right down here. They say that I squared is equal to just -1, and I is equal to the square root of -1. Because a square root and a square cancel each other out. So I would just have I squared equals -1, yeah? Make sense? Good? So those are the two things that you need to remember. That I squared equals -1 and I is the square root of -1. And then from there, it's just all algebra stuff. Okay? Are you ready?
No.
First problem. Simplify. We've already done one like this. The square root of -27. Can you take the square root of 27 exactly?
No.
No, it doesn't come out exactly. Okay, so we're gonna work on 27 over here.
3 out
3,
and
3.
1, 3 in.
Yeah. Okay. What goes in the bubble? 9 and 3, right?
Yeah.
Okay.
No,
Ooh,
it's
heavens.
on the left.
9 and 3, and we take the square root of both of those. So the square root of 9 times the square root of 3 will give me the square root of 27. The square root of 9 is 3, and the square root of 3 just stays. So 3 square root of 3. That's how that works, okay?
We never go farther than like the first two. Like we never split
Does
9
anyone
into
call you
3.
Mohammed?
What is
No.
that?
No.
Mohammed.
Correct. Okay? So the square root of 27 is 3 square roots of 3, except
Oh,
I want the square root of -27.
I.
So he needs an I. Where do you want to put the I?
After the 3.
Which 3?
First 3.
3i square roots of 3. Okay, or you can say 3 square root of 3i. I don't care. Whichever one. Just make sure that bottom one, the I isn't underneath. Right? Okay? All right. Moving on. Happy with that?
Yeah.
Okay, next. Moving on. Part B. How are we supposed to do 216? Holy cow, the square root of 216. Okay, here is your strategy. Are you ready?
You have one of these.
Yeah. You have them listed?
Yeah.
Yeah, there you go. Okay, 1 squared is 1. 2 squared is 4. 3. I'm writing out how you cheat right now. I'm writing it out. 3 squared is 9. 4 squared is 16. 5 squared is 25. Hold on. 25. 6 squared is 36. 7 squared is 49. 8 squared is, hold on, I can't write that fast. 9 squared is 81. 10 squared is 100. Okay, so I'm looking for numbers that go into 216 that I can take the perfect square root of. I'm looking for what goes in this bubble right here. So I start with, hold on, I start with 100. Does 100 work? Does 100 go into 216? No. Does 81? No. Does 64? No. Does 49?
I dropped my pencil.
No. Does 36?
Yes.
Yes.
36
6
times 6. 36 and 6. Okay? All right, so the square root of back up. The square root of 36 times the square root of 6 will give me the square root of 216.
6 times 9.
The square root of 36 is 6, and the square root of 6 just stays as the square root of 6, right? 6 square roots of 6. But since it's a negative, we need an I wherever you want to put the I. So you can put it here, or you can say 6 square roots of 6i. Whatever you want. Whatever you want. Yeah? Happy with that?
No,
Yes.
no, I'm not happy.
Okay.
I need to copy this down.
Okay, go for it.
Whoa,
Need the chart.
Oh, the chart?
Just use this.
No, I'm not. Alright,
It's cheating.
exactly. Only cheating.
I just erased what I didn't want to. Anywho.
Reese sheets.
Using resources.
Okay.
Working refresher.
So when you're breaking stuff down, use those numbers.
Actually, Reese sheets.
64.
81, 100.
Dude, I got
Okay.
We are good.
All right, moving on.
No, I'm kidding.
A. Here's why I like the i's. You treat an I just like he's a variable, like this was x, right? Okay. So let's say you had negative 5x times 3x. Don't change those to x's on your paper, but I'm going to do them on my paper. What is negative 5x times 3x?
Negative 15x.
Negative 15 x squared, right? Because you have two x's, right? Negative 15x squared, except it's not x. It is actually I. So it's negative 15I squared. Yes? Do we see how we get that number?
yeah.
Reese doesn't because he wasn't paying attention.
Yeah.
Squared. Because
But
there's
it
two
is
I's.
squared. So here's the deal.
Because there's
I
two I's.
squared, because there's two i's. There's two i's. I squared is equivalent to negative 1, right?
Yeah.
So instead of putting I squared, we're going to put negative 1 in there, right? So negative 15 times negative 1 is going to be
Negative 15.
positive 15.
Wait, what?
Yeah.
The I squared, we know that I squared from the top part right here, we know that I squared is equivalent to negative 1. So when we had negative 15 I squared, it's like negative 15 times negative 1, which is positive 15. Okay?
Yeah.
Good?
We're not 15.
Yeah.
Right? What? It's the answer is 15. That's how it
Okay,
simplifies.
so
That's
wait.
it.
That's
Oh my
weird.
gosh, you have your weird pencil.
We'll keep this.
Don't talk.
Okay, anyway, moving on.
I like it.
All right, let's go over here. This next one, I'm going to write them as i's first. So this is like saying the square root of 6i times the square root of 15i, right? Okay? Because that negative pops out as an I, right, when it's inside.
Yeah.
Okay? And then we're just going to multiply stuff together. So the square root of 6 times the square root of 15. Can I put
So
those
you're
two together?
telling me the square root thing turns into an I?
If it's the square root of a negative,
Okay.
the negative comes out into be an I. Yep.
Need
All right.
square root of 21.
No,
No.
because you're multiplying.
Square root of
Square root of
90.
90. The square root of 90. 6 times 15 is 90. But then what is I times I?
I squared.
I
21.
squared. Okay? All right.
did we get
Woo!
90?
Because
Multiply
6
them.
times 15 is 90. Yep.
You're slow.
So do we just
So
leave it?
9 times
Or
10.
Yeah, so we're going to break down 90 quick.
So 3.
Hold on. Dude, just wait. You're ahead of us. You're okay, Amit. Okay? Break down 9 and 10. What goes into 90? 9 and 10, we said break down 9 and 10. Okay. And then the square root of 9 and the square root of 10, but the square root of 9 becomes 3 and the square root of 10 becomes the square root of 10, right? Okay? So this is 3 square roots of 10 times I squared, really, right? But what is I squared?
Negative 1. So it would be negative 3 square root.
Okay, so 3 square roots of 10 times negative 1?
Negative 3.
Negative 3 square roots of 10. Does that make sense?
Hang on, no.
Okay, I'm pausing. Complex numbers, imaginary numbers, they are hard until you get the hang of them, and then it's not that bad, right?
Up to the,
Well, maybe if I would have known
Bang.
this before I took my
Controller.
maths test, maybe I would have gotten a higher score.
But you gotta have some growth in January, right? You gotta have some growth in January
Hopefully
when we
not,
take it
because
again.
No,
every
I don't
time
have to take
it,
math testing.
It's so hard to go up every time.
I don't have to
Actually,
take
I went up.
But now it won't be,
I
because
went
now
up
you know
6
something that you didn't know
I went
before.
up 6 points from last year, so.
That's not too bad. That's not too bad.
I mean, from compared to where I was last year to when
FYI, I didn't tell you guys this, and this doesn't include the sophomores, so we don't care about you sophomores, but you freshmen that are in here, who are my freshmen? There's not very many of you. Freshmen, you three, okay? Out of the freshmen in this class and the 6th period class combined, did you know that over half of you guys, like the freshmen, this class and the other class, over half of you are above the 95th percentile?
That's it.
Over half of the freshmen that
I'm over
I have.
the 98th
Over
percentile.
half of the freshmen that I have in any math class are above the 95th percentile.
what is the
Wow.
95th
That means you are smarter than 95% of the people in the nation. Over half of you.
Did you mean
It's
Not
okay.
everyone in the nation.
For the
takes
freshmen,
test,
not the
so-
sophomores, because you guys smell
Did
bad.
you mean
Not
the
really.
math testing?
There's smell that in
This
there.
I mean,
concept,
I'm
like,
taking
nobody
Yeah,
takes
Reese's.
this test.
I'm like,
How many people
Anywho.
take this test?
Everybody. all over.
I'm in
Procrastination.
I know people from different schools that don't take these tests.
What?
Maybe they don't have
People
guns.
from different schools that don't take these tests.
I don't know what they take. They probably take something different.
I would go
Anyway.
talk to her. So now you
Out of
know
all the people who take the maps test
When we
across
take
the nation.
What year did we take the previous?
I don't think I
videos?
believe
Or
I
do
don't
we?
You take that when you're a junior. You
Yep,
take the ACT
yep.
when you're a
All right.
junior.
Example 3. We better keep going, otherwise we're not gonna get done. Here we go.
Can't fail the ACT.
Example 3. X squared plus 64. Everybody look at this example.
I got above average on the ACT.
Look at this example. X squared plus 64.
-8.
You just wait. You just wait. Not yet. Not quite. Almost. X squared plus 64 equals 0. Here we go. This function right here is a parabola. That's a quadratic, right? That's a quadratic function. Okay, now quadratic functions usually have this happen, right? Okay?
Yeah.
And when we set them equal to 0, we're trying to find those places where they cross. We're trying to find these two guys right here. Yeah?
But we're not
Okay.
saying to make a linear
But sometimes they don't have two places where they cross. Sometimes they only have one place where they cross, and it looks like this. Right? We talked about that before. Yesterday, we talked about, not yesterday, Friday, we said maybe he only crosses once. Is there a scenario that happens where he doesn't cross at all?
Yes.
And he looks like this probably, right? Something of that nature. He's not crossing at all there. Okay, so let's look at what's happening. When we're solving for x here, okay, we would subtract the 64 over to the other side. X squared equals negative 64. And then we would do what?
Square root it.
Take the square root, right? Okay? What is the square root of, what's the square root of negative 64?
The 8.
8.
The 8.
8i.
8i. 8i, right? The square root of a negative is 8i. So here's what this happens, what this means, okay? This is saying that the x-intercepts are imaginary.
Wait, why
Okay.
did we square root them? If it's not in the original equation, why did we square root them?
Because you need to get rid of
Because we
the
have to get rid of the square on the x, right? Okay? So everybody listen to this. The fact that we got 8i as an answer means that our x-intercepts are imaginary. So in other words, he's crossing the x-axis at an imaginary place, which means
He's not touching.
he's not crossing. So he looks something like this, right?
Yeah.
So this, using imaginary numbers is giving us the solution when there is no solution, right? It's giving us a way of writing the solution when there is no solution. Make sense? Good? Okay. No?
So we did the whole squaring because the x was squared and we can't have an
And we want to get rid of the square, so we take the square root. Yes.
So
Okay.
All
All right, ready? Moving on?
now
We got a little bit left. We are going to skip a couple problems on the backside. But moving on. Here we go.
I'm good.
All right, complex numbers. A lot of times a complex number is like a marriage of a real number and an imaginary number. So if we take a look at this, 5 is a real number and 2 is an imaginary number. Okay? We have a real number and an imaginary number. And what they say is this is in the form of a plus bi. Okay? They say a complex number a lot of times is in the form of a plus bi. Okay? In this case, what is the a value? 5, and the b value is 2. So it's an a plus bi form. All right, let's go down here, and it says find the values of x and y that make blah, 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 blah.
Oh my gosh, that's what we had on.
Yeah, okay. So take a look at where your equal sign is. This is not hard to do, folks, actually. Okay? Not hard to do. There's your equal sign.
Just combine
Okay.
the terms.
And let's look at this right side here. You gotta listen. Let's look at the right side here. In this case, the 7 plus 6i, which part is the a part?
7.
The 7, which is the b part?
6.
The 6th. Okay, so b is everything that touches I. On the left side, what touches the I?
Y minus
Y minus 3 is the b. What doesn't have an I?
5. The negative 5.
The 3x minus 5. That
You
both
mean-
of those pieces
that's
don't have an I.
supposed to
Oh,
be
a. Sorry. A. That. Okay. So we're going to separate the a's and the b's out and make our own equation with the a's and our own equation with the b's. They don't want to be on the same equation together. And this is really not hard. A, we have 3x minus 5, that's the a part. But what's the a part on the right side? 7. So 3x minus 5 equals 7. And we're going to solve it. Okay? Here in a second. Well, let's write out the equation for the b part before we solve. What will that be?
Y minus 3 equals
6. Just 6. Yep. The a part is equal to the a part. The b part is equal to the b part. Does that make sense? It's really not that hard. Okay? Next, let's solve for the a. So,
Wait, that was easy.
yeah, solve for the a. We would add the 5. 3x equals what?
4. Wait, 12.
12. And then divide by 3. And x will be 4. So we've solved for x. Now we have to solve for y. And solving for y is even easier. You would
Divide the 3.
add the 3, add the 3, not divide the 3. Add the 3, because it's y minus 3, so you'd do the opposite. And y is 9, and that's all. You just set the a part equal to the a part and the b part equal to the b part, right? Anything that has an I is a b. Anything that doesn't have an I is an a.
Wait, what?
What? The b's were all of the I things, right there and right there. So it says the b is equal to the b's,
Oh,
Right?
okay, that makes
and the
sense.
a is equal to the a's. Yeah, right? Not too bad.
So you don't worry about like keeping the eyes in there or
No,
anything?
no,
Okay.
no, we don't care. We don't care.
Okay.
All right, on the back side, we have 3 more problems left. 3 problems left. Adding and subtracting. Here we go.
Wait, so then what?
Go to the back side. 3 problems left. We're gonna skip. We're gonna skip example 7 because that's typically what I do with my trig kids.
Oh, that's what I had.
Yeah.
That is what I had.
Skip
That was
example 7.
so
We're gonna
hard.
wait to do that. Okay.
That was so hard. I just
So we're
started.
skipping
Maybe later on in the chapter I might show you how to do that for bonus. I don't know. We'll see.
I was
Okay.
just-
All right, adding and subtracting. Adding and subtracting. Okay, we've got these 2 things together, and you treat the i's like a variable. So you treat the i's like an x. Yeah? All we need to do is add together like terms, and that's it. Okay, the first thing that I do is I drop the parentheses. So 5 minus 7i plus 2 plus 4i. I drop all the parentheses, and then I combine the like terms.
Why are they even there?
I don't know. And when it's adding, it doesn't really do anything. But when it's subtracting, we have to do something
So what did
kind
we
of.
say?
Okay.
Minus 3 eyes.
So 7 minus 3, yeah, right. So we combine like terms. 5 and 2
7 minus 3.
becomes 7.
Like that?
I don't know.
Yeah,
I
that's
love your
whack.
segments.
You just wait.
That is
I'll give you
whack.
a grammar lesson here in a little bit,
That's
but I'm not gonna do it.
grammar.
That's
I'll show you. Anyway,
Coach, that's like quite a bit of extra.
cool. All right. Negative 7i plus 4i is negative 3i. So there's my a plus bi stuff right there.
All you need.
That's all you have to do.
What
So
the
adding
heck?
is awesome. Now subtracting is just slightly harder than that because when you drop the parentheses, there's one thing you have to do first. Okay? And it is, can I go on to the other one?
Yeah.
It is this minus sign is negative for all of the pieces that come after it, right? So I have to distribute the minus sign there and there, right? So this will become negative 3 plus 6i. Does that make sense? Okay. Now the 4, the minus 8i, he just chills, right? 4 minus 8i doesn't change, but everything that's after the negative needs to be multiplied by a negative, right? Those guys are going to change, okay? And then all you do is combine like terms, right?
7 minus
So 4 minus 3
1.
is 1, and negative 8i plus 6i,
Negative 2.
negative 2i. There he is, right? Combine like terms, that's all, okay? Now, you're really going to like the multiply one. I really like the multiply one. A lot. I'm going to skip the story problem because on the story problem you don't have a, on the homework assignment you don't have a story problem. So what you're really just trying to do is take 2 plus 4i and you're multiplying by 9 minus 3i. That's what you're doing. You're trying to multiply those together, okay? Now, back up. Hold on for just a second. Let's take a look at these things here, okay? I'm going to take a look at these 3 problems that we just had, and on the test, when we get to the test, which will be a long time from now, but I have kids who on the test look at this problem, and they look at this problem, and they look at this problem, and they are confused as to what they are doing. So in this problem, how did I know that I needed to add? Because there's a plus sign in between, right? How do you know that you multiply, or subtract this guy? There's a minus sign in between them. But you would be amazed at how many times I have people that get to this and they treat this like addition. This is a multiply problem. How do I know it's a multiply?
They're close.
They're right next to each other, right? The parentheses are right next to each other, so that means multiply, right? It's not addition in between, it's multiply. So how do we multiply these two together? Yeah, F-O-I-L, whoever said that. That was Gabe. Thank you, Gabe. FOIL, F-O-I-L. You weren't here for FOIL, so listen. Okay?
Oh, is that like
F-O-I-L.
multiply with 2 with 9 and
Yes,
2
yes,
with
yes, 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 yes.
I know.
So you take the 2 times the 9 first, which is
18.
18. Then we multiply the outsides, which are 2 and negative 3i, which makes
Negative 6.
minus 6i, okay? The inside pieces, 4i and 9. What's 4 times 9?
36.
36i. And the last pieces, what's 4i times negative
Negative
3i?
12i squared.
Negative 12i squared, because there's 2 i's. There's 2 i's. Okay, now, this is what you should have written out for your FOIL, yeah? Okay, now, before we finish anything else, before we combine like terms, I want you to do this one thing. We know what I squared is. I squared is negative 1, right? So, negative 12 times negative 1 is going to turn that into a plus 12 rather than a minus 12. Do you see that?
Okay.
Okay, now I'm going to combine like terms. So, 18 plus 12 is going to be 30. And then negative 6i plus 36i
30i.
is plus 30i. Yeah?
I told you you were wrong.
Happy with that?
No,
Yes.
as happy as I'll get, it's math.
As happy as you're going to get. All right.
Is it really?
So,
If you're wrong, you're wrong.
Oh my goodness.
woo.
Oh no.
Oh my back.
Okay.
So bad right now.
Okay. All right. Going on down. I picked some weird problems on the homework assignment. It's only front-sided, but I do like cross off some of them. So I'm going to leave this up here and I'm going to give you your homework assignment and then I'm going to have you guys go.
Eliminated.
You got some weird stuff for homework.
Wait, Mrs. Scott.
Just wait.
I didn't write my name for homework.
Yeah, because you don't carry this minus sign, right? Because adds, these two adds, so you don't carry this minus sign.
So which ones do we do? We do 1, 2. It says on the board.
That's a bigger one.
Okay.
It's like 36 minus 6.
Oh my
All right. So here, ready? Circle. Ready?
I'm trying.
Circle these. 1, 2, 5, 6, 7, 8, 9, 10. You skip 13, go to 12. 13 and 14 you do. Skip 11 and go to 12, not 13. Skip 11, go to 12. Do 13 and 14 and skip 15 and 16.
Wait, what?
Wait, do you do 12?
Yes, you do 12.
Yes.
Yep.
Okay.
Okay?
Hey, go back, huh?
I could also show you mine. I have them also.
Okay, on the bottom, just do 18, 20, 25, and 26 out of those sets. 18, 20, 25, 26.
Alright, too easy.
Okay? All right, you're going to have questions on, because you're not going to know how to do 8 and 9. Would you like to do one of those together now, or do you want to wait till tomorrow?
Tomorrow. Tomorrow because maybe. Tomorrow because maybe
We
you
can
could
do
just
one-
try it.
we can
Maybe
do-
you can do it.
We can do one now and one
No,
tomorrow.
let's
I go to the
go
bathroom?
both tomorrow.
Let's try one.
All right, we'll wait till tomorrow, but I'll go help Reese, and I'll teach her how. Here in a second.
And then Reese can teach me.
I want to know.
Okay? And Caitlin, I'll teach you both. Okay? All right. Okay, I'm going to stop the video. 8 and 9. Yep, I'll teach you 8 and 9. Here we go. That's the trick. Everybody say bye, people on the video. They don't care. They don't care about you.